in PhD now, like the way it's improved so much, it can pretty much do everything for you. I'm pretty sure if you really tried, you could get it to do pretty much a whole paper for you, like from coding to writing. Maybe in 10 years, you'll see people doing their PhDs fully on Claude and ChatGPT.
What do you actually spend most of your time doing as a PhD in astrophysics?
I think most people give the same answer to me, which is reading and coding. Because, these days it's less about going and actually operating the telescope and, physically by hand. So most telescopes now are robotic. You put in information, they collect the data by themselves. And then once you have the data, pretty much from there, it's programming. You're trying to get the raw image and make it look presentable. You're trying to get specific outputs from the image. You're trying to run some data analysis and all these type of things, which 99% of the time is just programming. And the reading part comes in terms of what are we going to use this data for and what have people done before, or even just trying to understand what we're looking at, So, those are pretty much the two main things.
Is that something you can expect nowadays, like you said, because everything's becoming automated? If you're looking to become a PhD in astrophysics, should you expect to begin coding or learn coding?
100%. I was even just thinking through, is there anything we don't use coding for? Because, I talk to a lot of people in different areas of astrophysics, like stellar astrophysics, where you try and understand how, like the mechanisms of stars, or galactic astrophysics, understanding how the galaxy works, or extragalactic astrophysics, where you understand different types of galaxies. And you always need to have some coding skills, some more than others. Like for me, due to the nature of what I'm actually working on my PhD, is more technical than what most people would do. But to some degree, you need to. But the good thing with coding also is that it's very, what is it called? Coding is a transferable skill, If you're in your undergrad or master's degree, you don't necessarily have to have done astrophysics. As long as you do some practical use of coding that could be transferable to what your PhD will be in, then it's all good, yeah.
Galaxy Zoo, is that, if I'm correct, like a kind of open source, I don't know how else to put it, open source way of researching?
It's like open source, community oriented. So what happens is, it's a platform. What essentially happens is, you as a scientist, let's say I'm a scientist, right? And I'm trying to investigate something about galaxies and I have 10,000 images. Instead of looking at every single image by myself, I can upload these images to the website and ask viewers to pick out things that they think is interesting or that they think are interesting. So they could pick out spirals, bars, anything like that. And I would aggregate the results, see what they say, and I have my results there, It's a way for interesting new things to be discovered. It's an interesting way to get an insight into, what people pick out when it comes to certain galaxies and things like that. So it's a very community-oriented open source platform, Volunteers can engage, ask questions from the experts. The experts can get feedback on all these things. And occasionally, a lot of the volunteers will be put on a paper, on a research paper because of their discovery. So,
Or do you use like artificial intelligence to kind of sift through large data sets to help you out?
Yep. Yes, indeed. I actually did some work for a paper led by Mike Walmsley. He essentially made a machine learning model called Zoobot. So machine learning is a very broad term, but in the way we use it, it's an algorithm you can train to pick out certain features in something you're looking for. Like, for example, classic example is a dog. You give this algorithm 1 million pictures of a dog. And then you'll say, you give it a new picture it's never been seen before, and you say, is there a dog in the picture? It'll be very good, right? So what I use Zoobot for, I kind of like, what is it called? I increased the training. So I trained it on a new data set of images based on responses from Galaxy Zoo volunteers to help me look for new objects. Fine-tuning. Fine-tuning is the term where you have an already trained model and you just add a few more images to train it more on different things it hasn't seen before. Yeah.
But within astrophysics specifically, is AI viewed as more as a threat or a useful tool or kind of both?
So far in astrophysics, it's very much looked at as a useful tool. But again, it depends on the context. So there's two contexts. If you're actually doing a project using machine learning, where you're trying to train it for images or, helping it improve your efficiency in coding, or trying to apply it to things that people already do. Very good. People love that, actually. There's so many papers, and it's encouraged because with new tools comes new efficiency, generally speaking, new improvement in tools. But in general, a lot of people against using AI to help you write papers,
of course,
to write your code, to write research proposals. There, people are more against AI and machine learning. But in general, practical use cases where it can help improve the output of science, generally people are more in favor.
How is it seen or used within the more of the school side of things, and like you said in paper?
Well, yeah, like when I was in undergrad, ChatGPT just came out in maybe my last 6 months of undergrad, and it was terrible. Like, we all tried using it, even the lecturers and everyone was like, I wonder how good it is at this physics. It was terrible. Like, we just had to learn. In PhD now, like, the way it's improved so much, it can pretty much do everything for you. It can do your coding, writing. I mean, it depends how you use it and depends what you're studying, but I'm pretty sure if you really tried, you could get it to do pretty much a whole paper for you, like from coding to writing. Claude, all these different types of tools, DeepSeek. But people don't really use it that much because, a lot of work that you do is your own original idea. And it's a combination of work you've done in the past. So maybe in 10 years, you'll see people doing their PhDs fully on Claude and ChatGPT. But for people these days who started when it wasn't that good, for us, we still do things manually, the old-fashioned way.
And do you think at some point, though, that AI could detect something real in space before scientists even understand what it's found?
Well, yeah, I think so, for sure. I think so. We're even using machine learning right now in huge collaborations and data sets to look for things we don't know. We know there's things we haven't seen, we don't know yet, we don't understand. So yeah, we're using, even me, one of the papers I'm working on is using machine learning to try and understand the behavior of certain objects and certain classes of objects and things like that. I haven't really fully finished with the studies, but there's a lot of promising work that can come from this.
Yeah, for sure. Now, how do you check whether the data that it found is something real rather than just noise, or maybe something like that?
Yeah. Well, there's you can just there's a lot of ways you can check. It depends on the data you're looking at. Like, let's say it's looking through a set of images. We'll just check the image, that it hasn't done anything to the image is fine. A lot of the times it's just looking for something. We'll just look at the source, investigate, and we're like, oh, okay, it's a crazy source that we've never seen before, or it's normal. That's pretty much it.